Hello students, welcome to my YouTube channel Dear Mathematics, and also welcome to the topic of differential equation. It is the first part of the topic differential equation. Here we are going to discuss about the definition of differential equation, some of the examples based upon differential equation, then order and degree of the differential equation, and some of the basic problems based upon the order and degree of the differential equation. So first of all, let us go to the definition of a differential equation. An equation containing differentials or derivatives is known as differential equation. Alternatively, we can take the definition as an equation containing an independent variable and a dependent variable and the differential coefficient, that means the derivative of dependent variable with respect to the independent variable, is called as a differential equation. Now it is the time to take some of the examples of differential equation. So here it is the first example, dy upon dx plus 3y is equal to x. It is a differential equation. How it is a differential equation? Here the independent variable is equal to x and the dependent variable is equal to y, and this is the independent variable and here it contains a dependent variable, both are here, and then we have to find out the differential coefficient of a dependent variable with respect to the independent variable. So the differential coefficient of a dependent variable with respect to the independent variable, it is dy upon dx, and here it exists dy upon dx. So it is a differential equation. We can consider some of the more examples which are differential equation. You can consider as d square y upon dx square plus x square is equal to root x. It is a differential equation. Then you can consider again also d square y upon dx square is equal to square root of 1 plus dy upon dx. It is also a differential equation, and these are some of the differential equations. Then you have to go through the different types of differential equations. Here we can write down differential equation is of two types. Differential equation is of two types. The first one is ordinary differential equation and the second one is a partial differential equation. So you can write down differential equation is of two types. The first one is ordinary differential equation, ODE, ordinary differential equation, and the second one is PDE, partial differential equation. Then let us go through the definition of ordinary differential equation and partial differential equation and some of the examples. Then we have to go through the order and degree of the differential equation. Then let us go through the ordinary differential equation and partial differential equation. First of all, let us go through the definition of ordinary differential equation. When an equation contains derivatives with respect to a single independent variable, then that differential equation is called as an ordinary differential equation. And then going through the partial differential equation, if a differential equation is said to be partial differential equation if it involves two or more independent variables in it. So these are the definition of ordinary differential equation and partial differential equation, which will be studied in the higher class mathematics. Now let us go through the order of a differential equation and degree of a differential equation. Then let us discuss about the order of a differential equation. The order of a differential equation is the order of the highest order derivative term. That means h dot o dot d dot t, highest order derivative term in the differential equation. Then going through the degree of a differential equation, the degree of a differential equation is the degree of the highest order derivative term. That means the degree of the highest order derivative term, it is called as the order, and this is called as the degree. This is the order and this is the degree. But first of all, you have to choose the HODT, that means the highest order derivative term present in the differential equation. Then that is the order of the differential equation, and the degree of the highest order derivative term is the degree of the differential equation. But before going to calculate the order and degree of the differential equation, first of all we have to check that we have to express the differential equation in such a form that which is free from the radicals and fractions in its derivatives. That means we have to express the differential equation which is free from radicals as well as the fractions. Then after we have to find out the highest order derivative term, then that is the order of the differential equation, and the degree of the highest order derivative term is the degree of the differential equation. So let us go through some of the examples based upon order and degree of a differential equation. But before going to the examples, let us again discuss about what is the highest order derivative term. The differentiation of y with respect to x is denoted of y dy by dx, and we have differentiated y with respect to x single time or first time. So here order is equal to 1. Then again differentiating, that means dy by dx to be differentiated. That means differentiating dy upon dx with respect to x, that means derivative of dy upon dx with respect to x, that means it is d square y upon dx square, and here order is 2, that means y has been differentiated 2 times. Similarly, again differentiating this term with respect to x, we can also get differentiating d square y upon dx square with respect to x, that means derivative of d square y upon dx square is given by dqy divided by dxq, and here you can say that order is 3. And then let us consider or compare the derivatives here. So here you can say that order is 1, order is 2, and order is 3. Order is 3 means the dependent variable has been differentiated 3 times with respect to the independent variable. Then let us compare them. If dy upon dx and dq upon dqy dxq is given to you, which is the highest order derivative term? It is the highest order derivative term, and here order is equal to 3, and then we have to find out the degree of the highest order derivative term, and here it is the degree of the highest order derivative term is 1, so degree is equal to 1. So in this process we have to calculate the order of the differential equation as well as the degree of the differential equation. So let us consider some of the examples based upon it. So here these are the examples based upon the order and degree of the differential equation, and here it is the first problem. The differential equation is like this: d square y upon dx square plus 3x multiplied with dy upon dx plus 5y is equal to 0. First of all, we have to find out the highest order derivative term. That means the HODT, and you can see that here y is differentiated 1 time and here y is differentiated 2 times. So this is the highest order derivative term, and the dependent variable y has been differentiated 2 times. That means order is equal to 2. So then we have to find out the degree of the highest order derivative term, and the degree of the highest order derivative term is 1. So degree of the differential equation is equal to 1. Then let us go through the second problem, and here there exists a single differential coefficient of y with respect to x. That means it is the only differential coefficient of y with respect to x, so that is HODT. That means highest order derivative term, and here y has been differentiated 1 time. That means order is equal to 1. Then the degree of the highest order derivative term, it is again 1. So degree is also equal to 1. Then let us go through some of the other problems. Here is the third problem based upon order and degree of the differential equation. So given that d square y upon dx square is equal to square root of dy upon dx plus y. From here we cannot find out the order and degree of the differential equation, because First of all, we have to express the given differential equation in such a form that it must free from radicals and fractions. So then at the time we can find out the order and degree. So squaring both sides. Okay, you can also write down here this line. Squaring both sides. Squaring both sides, we have then here we are getting d square y upon dx square, it is equal to dy upon dx plus y. And here you can see that the highest order derivative term is d square y upon dx square. So this is the this is square. This is the highest order derivative term, and here order is equal to 2. This is the order because y has been differentiated 2 times, and the degree of the highest order derivative term is the degree of the differential equation. So degree is equal to, again it is equal to 2. Then let us go through the fourth problem based upon this category. Then coming to the next problem, it is ln dy upon dx is equal to x. So by using the concept of logarithm, we can write down dy upon dx is equal to e to the power x. So from here you can see that this is the highest order derivative term. So order is equal to 1 and degree also equal to 1. Then the next problem is here. First of all, we have to express this differential equation such that it must free from radicals and fractions. So just multiplying, we have to the power 3y2, it is dy upon dx plus 1. Squaring both sides, we have, it will be d square upon dx square to the power 3, it will be dy upon dx plus y to the power 2. And this is the highest order derivative term. And from here you can see that the term y has been differentiated 2 times with respect to the independent variable x. So order is equal to 2. And the degree of the highest order derivative term is the degree of the differential equation. So degree is equal to 3. And this is the answer for the problem number 5. Then coming to the problem number 6 and 7. Then coming to the problem number 6, it is given that log 1 plus d square y upon dx square base e is equal to x. So according to the concept of or the fundamental principles of logarithm topic, we can write down here 1 plus d square y upon dx square is equal to e to the power x. That means this is the highest order derivative term. And here you can see that the term y or the dependent variable y has been differentiated 2 times with respect to the independent variable x. That means order is equal to 2. It has been differentiated 2 times. And the degree of the highest order derivative term, it is 1. So degree is equal to 1. Then coming to the last problem of this concept, that means order and degree of the differential equation. So here it is the last problem of this kind of video session. It has been given that 1 plus dy upon dx and this whole square whole to the power 3/2 is equal to d square y upon dx square. First of all, we have to express it in such a form that it must be free from radicals and fractions. Squaring both sides, we have squaring both sides, we have whole to the power 3, and the right hand side will be in the form of whole to the power 2. And you can see that this form is totally free from radicals and also fractions. And here you can see that this is the highest order derivative term, because here y has been differentiated 1 time. and here y has been differentiated 2 times with respect to the independent variable x. So this is the highest order derivative term. As it has been differentiated 2 times, so order is equal to 2 and the degree of the highest order derivative term is also 2. So degree of the differential equation is also equal to 2. So here it is all about the problems based upon the order and the degree of the differential equation. So particularly in this first part of the differential equation, or in this particular video session, just we have discussed about the definition of differential equation, some of the examples based upon differential equation. Then we have discussed about the different types of differential equation, that is ordinary differential equation, partial differential equation and their definitions, and then we have gone through the definition of order and degree of the differential equations, and then some of the problems based upon the order and degree of the differential equation. In the next video session, we are going to discuss about the formation of differential equations and the different types of solutions of differential equations. Till then, thank you.